As we know, x cannot equal -1. So the function is undefined. It cannot be continuous. So I think everyone noticed that. So not continuous at x equals -1 because it's undefined. Undefined. That's the reason why. Now, when we want to identify what type of discontinuity it is, we know that we have jump, we have infinity, and removable. Please remember, removable is only when the denominator disappears completely with a factor in the numerator. That becomes the whole or removable. But if the denominator stays and it doesn't go away, you cannot simplify. There is no factor of x plus 1 at the top. Because there is no factor of x plus 1 at the top, this cannot be removable. It's not a jump, and it's not removable because the factor stays. So it is indeed an infinite discontinuity. So, is that clear with the removable? The removable will be this or whole or removable only if the factor in the denominator disappears, or and I still have, let's say, x minus 1. This is a vertical asymptote, but this is a hole in the graph or removable. If it doesn't go away, it cannot be removable. And this one does not go away. So it will be infinite. Okay, good.
Can you say the jump one more time? I'm sorry.
Yes, yes. The jump is how we determine the jump. Very good question. So we find the limit as x approaches -1 from the left, and the limit as so you're saying how we get the jump? I'm sorry. I think you're asking about the jump, not about the infinite, right?
Correct, the jump.
Okay. So let me just finish here. So you will see that this is an infinite discontinuity because when you plug in -1, so the numerator is positive no matter what at -1. But the denominator here with -1 from the left will end up being negative infinity, and with -1 from the right will end up being positive infinity. So that's why this is an infinite discontinuity. Now the jump, I have to have something like this. So that's not possible for a rational function to have a jump. It's possible for a piecewise defined function to have a jump, but not for a rational. Was that the question, Amanda?
Yes.
So this is not for a rational function, not rational.
Okay.
So this is a typical situation when I have a piecewise defined function. So f of x, I don't know, x squared for x less than or equal to 0, and x plus 3 for x greater than 0. I have 0 here on this side, and I have 3 here on this side. That would be a jump. Is that okay?
Yes, thank you for clarifying.
Thank you, of course.
If
Okay.
something is undefined,
Yes.
does that always mean it has a discontinuity?
Yes. If a rational function is undefined like this one. Also, very good question, awesome question. Hold on, I'll come back to that in a second. So here's another example. So if I have f of x, which is tangent x, which is sine x divided by cosine x, well, cosine x cannot be 0, but cosine x is 0 at pi over 2 and 3 pi over 2. That's why tangent is undefined at these 2 points. And that's why when we graph the tangent, we graph the vertical asymptotes first. And it goes on forever, left and right. So then I graph tangent. Because the denominator is 0, at pi over 2 and 3 pi over 2. So this is negative pi over 2, pi over 2, 3 pi over 2, and so on and so forth. Because cosine is 0, the whole fraction is undefined. That's when we get to the vertical asymptotes. Is this clear? Any questions on this? Is it enough explanation, or is it understood? So it doesn't have to be a rational function. If the denominator is 0, the function is undefined. Now, if at -1, if the factor disappears, that will not be a vertical asymptote, but the function will still be undefined. This function is undefined at 2 points, 2x values, -1 and 1. Even if it simplifies now, let's say to 3 minus x, x minus 1, still is undefined at plus or minus 1. One being a whole and the other one being a vertical asymptote.
Okay, thank you.
Thank you. Very good questions. Thank you. Okay, so where are you guys? I'm clicking and clicking and clicking. Okay. So where is my book? Here's my book. Okay. So let's continue. We had a rational function. We had a rational combined with radical. Now we have to choose one from these. One from the ones with radicals, like this. 23, 24, 25, 26. We have to look at one of those. Okay, I will choose. I want one with negative. I will choose 27. You'll see in a moment why. 27, we have limit as x approaches negative infinity. The numerator is 2. Oh, no, this is not what I meant. Sorry. Now we have to finish it because I wrote it. Sorry about that. That's not what I meant. But I wrote it, so let's finish it up. It's fine. It's a good practice. So we also have to look at something like this. But what I had in mind is 26. Okay, I wrote 27, and I'm going to copy 26 as well. So I can stop sharing. So limit as x approaches negative infinity, the square root of 1 plus 4x to the 6th over 2 minus x to the 3rd. Okay, perfect. I managed to copy from 2 problems. I'm very good at that. No, this time no. Oh, wow, good. Okay, so we'll keep this on the side for a moment. So let's work on this. You will say the numerator is going where? You will say the denominator will go where? The target, we mean. What is the target for the numerator and the target for the denominator?
Negative infinity.
And the target for the denominator?
Infinity.
Awesome, perfect. Great job. So we know the degree at the top is?
Nice.
Yes. So we have to factor out the degree. Do not combine them. I know the book shows something else. It's a waste of time. That's my opinion anyway. What is the degree of the denominator?
4.
Yes. And now two terms. One here has minus and the other one has plus. We need to make sure that we correctly identify the terms such that this times this is this, this times this is this, this times this is x to the 4th, and this times this is 3. Which terms will I put in there? Because it has to be correct. It's okay if you're wrong. Let's discuss this, please. Anyone?
2 minus 1 over x to the 4th.
So obviously x to the 5th over x to the 4th is x, so that's it. Perfect. The denominator. Yes, I know it's 1. Three over
X to the 3rd.
good. X to the 4th. Perfect. Good. I was dying to do this. Where is this going? Of course, when x approaches infinity or negative infinity. These are connected here, of course.
0.
Awesome. Where is this going?
0 as well.
Of course. Don't forget the x in front and 2 over 1. When x approaches negative infinity, what do I write?
That be negative infinity.
Negative infinity. Since the limit is as x approaches positive or negative infinity, and the answer is negative infinity, no horizontal asymptote. Horizontal asymptote requires this to be a number, and this is not a number, this is a symbol. No horizontal asymptote. Any questions? Any questions? So this is what I wanted, but this was a good example. So 26, limit as x approaches negative infinity, the square root of 1 plus 4x to the 6th, 2 minus x to the 3rd. Let's start with the denominator. Where is the denominator going? What's the target? We are not saying it attains the target, but where is it going? This should not take that long. Please. Please.
Infinity.
Say it again.
Infinity.
Of course. Because we have negative infinity to the 3rd, which is negative infinity, with minus in front would be infinity. Okay, now careful here with the numerator. Let's take it piece by piece. Where is x to the 6th going when x approaches negative infinity? Just this piece right now.
Positive infinity.
Perfect. Times 4, who cares? Plus 1, who cares? The square root of positive infinity is infinity. Okay, so there is hope. Remember, 0 over 0 has hope, infinity over infinity has hope. We don't know. It could be anything. But they have hope initially and at least. Perfect. So now the limit as x approaches negative infinity. What is the degree of the polynomial under the square root? I need the degree of the polynomial under the square root.
6.
Degree, 6. Perfect. So we are going to factor out x to the 6th. Inside the radical, don't do anything yet. Else. I need two terms in here. Can anyone? Yes, ready?
4.
So it's first of all, it's, yes, so this one is 4, but what about the first one?
1 over x.
To the 6th. Awesome. Perfect. Brilliant. Now, what is the degree in the denominator?
3.
Yes. So I have to factor out x to the third. Now I need two terms such that this times this is this times this is this. Of course with minus in between.
Two over x cubed.
So first of all, it's 2 over x cubed and minus 1. Let's check. X cubed times 2 over x cubed is 2, because you simplify these two. This times negative 1 is that. Do we agree with this? Everyone?
Yes.
Perfect. Okay. Now, this is the key. At this point, this is the key. Remember the square root of a product. The square root of a multiplied by b is the square root of a times the square root of b, assuming everything is real. Otherwise, the property is not applicable. But we assume everything is real. So I have to write the square root of x to the sixth times the square root of 1 over x to the sixth plus 4. That's our next step. This is very important. A very important property. So limit as x approaches negative infinity, the square root of x to the sixth times the square root of 1 over x to the sixth plus 4, everything divided by x to the third, 2 over x to the third minus 1. Okay, now, the square root of x to the sixth when x approaches negative infinity. Don't say anything, please, just yet. Don't say anything. You remember that the absolute value of x, Monday we talked about this. We reviewed the absolute value, the formal definition of absolute value, and we applied it. It's x for x greater than or equal to 0 or negative x for x less than 0. You told me this. Why am I referencing this here? Why am I talking about it? It's because of the square root of x to the sixth. The square root of x to the sixth is the absolute value, 6 over 2, of x to the third. This has to be a positive number. If you write x to the third without the absolute value, this could be negative. So it has to be positive equals positive, which gives us these two options. So this is x to the third when x to the third is greater than or equal to 0, or negative x to the third when x to the third is less than 0. Because this is very important. I don't know if to write x cubed or to write negative x cubed, but I know, because this tells me what to write. So what do I replace this by? X cubed or negative x cubed? And the answer depends on this.
X cubed. Negative x cubed.
Exactly. Negative x cubed. So careful, this is negative x cubed because of x approaches negative infinity. If this were positive infinity, I would have chosen x cubed. But because x approaches negative infinity with negative in front will guarantee a positive number here. So this means jump over all this and continue here. So this is limit as x approaches negative infinity, negative x to the third, the square root of 1 over x to the sixth plus 4, everything over x cubed, 2 over x cubed minus 1. Now it's done. That's why I wanted to squeeze it here on this page. Where is this going? And where is this going? When x approaches negative infinity. Or infinity, doesn't matter. Where is this going? And where is this going?
0.
Yes, these are 0. So now, I have -1 in the denominator. I have the square root of 4 in the numerator, but I also have a negative in front. That's all it's left. These are gone. There is a negative sign in front. There is a square root of 4, and there is a -1 in the denominator. I covered everything else that disappears. So therefore, the answer is
What's on -2?
so there is a negative that will kill this negative,
Okay.
and we have the square root of 4. I know everyone knows what the square root of 4 equals to. I have no doubt.
2.
2. Negative, the square root of 4 will be -2 divided by -1. The answer is 2. I have to write y equals 2 horizontal asymptote. But I absolutely have to write, guaranteed, this is not a rational function. It's a combination. Guaranteed at -infinity only. How come? It's guaranteed